Hi everyone. This is going to be the second episode for our series, which is on machine learning fundamentals. We are going to exactly take it from the same point where we left the previous episode, episode one, in which we have discussed, in fact, what is machine learning, the definition of machine learning, what are different types of machine learning, and we have given some intro to them. uh, Episode 2 will be we'll be deep diving into one of the major types of machine learning, that is supervised learning. So we will deep dive into supervised learning. We will just see, different aspects of it, and then we'll be giving certain examples as well. We'll provide some examples as well, and we will reach to the point where, in fact, we can just take some pragmatic concepts. Certainly, this particular video or episode 2 of this series will not cover anything practical, but definitely we'll be reaching to that point where from we can just take certain examples, probably in episode 3, basic examples for this supervised learning, and we can implement them using Python language. So we can just kickstart this second episode of this series, which is machine learning fundamentals. Uh, Fundamentals of machine learning, and in this one we are now into supervised learning. What is supervised learning? We have discussed it already last week, last episode. So that was the episode 1, which we have already discussed. So supervised learning, we are going to deep dive into it. A visual, beginner friendly explanation of how machines learn from labeled examples. So we will be providing some basic examples how machines can learn from data which is labeled, the labeled data. So we have discussed it already, in fact, the labeled data, unlabeled data. In fact, we have discussed about that, but we'll be deep diving into this, that from the labeled data, how machines can learn, and then how they can make predictions and avoid common mistakes. So, how machines can learn from, definitely learn from this labeled data, how they can make predictions, and the mistakes, common mistakes which are there that happen in these, this supervised learning, how those can be avoided. So if you just see on this exhibit, which is on the right hand side, it is showing again the same example which we had used in the previous episode, previous video, which was of first video of the series. That was, training. It is training the data on the students. It's a student's data, student's performance. Number of hours studied, and what was the result, and then it is giving that data, and then we are inputting number of hours studied is 5, and it is predicting the result as pass, and in fact correctly. Where supervised learning can appear in real life, we are going to discuss, actually, before I just go to this, I want to keep this second episode as short as 15 to 20 minutes, not more than that. So I want to give you a brief, very brief on, and at the same time give the insights about this supervised learning, because we are going to consume some time, good time, on the practical implementations of various implementations that can be done in supervised learning. I'll be trying to give maximum examples practical, and we'll be implementing that on Python. It's going to be a little bit, videos or episodes which will be lasting for half an hour or 45 minutes. Where supervised learning appears in real life, where we can implement it. So it can be implemented in email filters, banking, healthcare, education. So all of these are the examples of where, supervised learning can in fact be implemented. So core idea, we already know that correct answers for the past data which is there. So the model learns mapping from inputs, and then maps them to outputs, and then in the future it can make predictions. Learn patterns and predict unseen cases. So definitely it will be predicting those cases which have not been seen. What supervised learning means? the training data already includes the target label, so it is already having the label in it. So labeled examples are there. For example, hours studied. Somebody who has studied 2 hours, for example, it is the data which has been already fed into the model. Somebody who has studied for 2 hours has failed. Somebody who has studied for 4 hours has passed. Somebody who has studied for 6 hours has passed. Model is learning from this data. This is just an example data. So it will be a huge collection of data that will be fed. It will be having a lot of complexity as well. It will be having different feature set, and based on that it will be learning from that, and then it can predict. So it is giving an example. If for example we are saying that number of hours a student has studied, a new case which is 5, it is not existing in any of those cases. If you just see on the left hand side, this is very important. So that means it is not a simple matching here that happens. A model is not simply matching something that it has seen previously, it's learning. So learning is different from matching. So it's not simply matching something that is already existing in the previous data. No, it is learning from that pattern. So that's why this existence of 5 is nowhere there. If you just see hours studied on the left hand side with the data with which it was trained, it is not there. And then we are saying 5 hours, that is not there in that, but it is predicting that this particular student who has studied for 5 hours should be passing based on the previous data patterns that it has learned. So very much clear here that it is not simple matching of the labels. No, it is the model is learning, and then based on that learning it has taken, it will be predicting the new cases. So a supervised model does not guess blindly. It studies many labeled examples and learns the relationship between features and the known targets. So this is precisely what I was trying to highlight. uh, why labels matter? So why do labels matter? So labels matter. Without labels the model sees only the raw data, so it cannot see anything else. It can see just the, for example, image A, image B, image C. There are multiple images, so we're saying A, B and C. But it does not know which answer is correct. So with labels, what can happen? We are telling it that if it is image A, it's cat. Image B, it is dog. Image C, it is cat. So these are the labels, clear labels. Now each example tells the model what the correct answer should be. The mapping becomes learnable, so it becomes very much learnable for it. And a good mental model, features are clues, labels are answers, definitely. Training finds the rule that connects them. So when we are training a particular machine learning model, so when we train it with the data, what it finds is, it finds the rule that is connecting them. It is not a simple rule which we are otherwise giving. No, it is actually, it learns how I can match if a future occurrence is coming or future case is coming, which is even not matching whatever current data, any of those directly. It is not matching, but based on the data which has been given, it will be able to predict the outcome. So this is what precisely happens in the supervised model. And then if you just see, we have discussed it already, regression and classification. So if you just see, regression will be, in fact, it will gradually increase as the number of hours studied is increasing. We can just see it is having a similar increase in the scores as well. So you can just see that line which is increasing. Regression predicts a continuous value such as a score, price, or temperature. So definitely with the increase in student hours, studied by a student, hours studied by a student, the score is increasing on continuous basis. And it can happen similarly with other types of numbers. For example, it can be price, it can be score, it can be temperature. On the other hand, if you just see classification, it can predict whether a student has failed or passed. So it will be putting either a student in category A, class A, or class B. Class A means those students who have not been able to, who have failed. So failed students and passed students. So it will be putting them in two categories. in this case. So there might be some other cases, but we are talking about pass or fail. Or for example, a mail is a spam or not a spam. So it can put it in two categories. In the same manner, we can have one more case whether a particular transaction is a fraud or a normal transaction. So these are some of the cases which we can just see. And in fact, training data and test data are not the same thing. Definitely, when we are getting a data set, uh, we are dividing that data set initially so that we can first of all train a model, and then we can test it. So normally what is used is we are using different percentages. For example, sometimes it is 75-25 or 70-30, where 70% of data is used to train a model, and then other 30% which is there, that is used to test it. We don't use same data which has been used to train a model to test it again. So that is not a good practice. What is a good practice is random split, stratified classes, and no data leakage. So this is something which we have to remember. Train on examples, and then test on example models that have never been seen. So you are training a model on those examples you are aware about, you are having in hand, and then you can test the model to see its real capability of prediction, or how much, what is the accuracy and rest of the other aspects which we are going to discuss, in fact. So we can just see if we are testing the model on the data which has never been seen. So these are some good practices which we should be doing, in fact. And then there are certain problems, in fact, that can happen. For example, underfitting can happen. A model is given some data which is very simple, too simple to learn the pattern, and then it gets carried away with that. So it is, underfitting. That's called as underfitting, a problem of underfitting. The goal is not perfect memorization. The goal is reliable generalization. Actually, what is our motto behind in machine learning is we are not matching values to some other values which are there. It's not that that will be something, a pattern is so simple that it's not learning anything. So that can happen that it doesn't learn anything. A good fit, if you just see, it captures the signals and generalizes. For example, if you just see this line, so you might see a little bit of a deviation towards left and right. That is a perfect curve actually, which is there, which is a good fit. So that's a good fit, and it is able to actually accommodate those things. And if you just see underfitting, it is just just a simple line, a simple thing to learn, and then it can just machine learning model can always give the same thing. So that is underfitting. Good fit. And what is overfitting? It memorizes the noise. Noise is some wrong values or wrong predictions which are there, or wrong things that are there in the data. So it goes to them, and then we can see this, noise instead of a pattern which is there. So this is not a pattern. I think this particular diagram which is given now, it will be much more clear with the next slide which we are having. So this is best model is low error on new data, not just old data. So it will be having low error on the new data which you are giving, which it has never seen, and as well as on the old data. If you just see, this is the figure which I was talking about. So what is underfitting, what is good fit, and what is overfitting? So if you just see this data, uh, underfitting versus good fit versus overfitting, you can just see these curves which are there. Okay, so we are able to see, if you see the good fit, which is an orange line which is there. Now if you see overfitting, you can just understand what overfitting is. High degree, it's going up and down, different things, and then it makes a curve here. So it will be actually predicting certain things, which will be in fact wrong. So it can give us huge number of false positives and false negatives that can happen. If you just see an underfit, it is a straight line. It's coming almost a straight line. So it neither goes there nor comes here. That means it will not be able to have, it will not be having capability. It will be deviating towards one end. So based on the data, it's learning that pattern as if it is very simple. So it will be putting it, it doesn't learn, it is actually matching the values. So that will be too simple. That's called as underfitting. And with both underfitting and overfitting, we are having problem. So these are problems which can happen based on different use cases and then the kind of data you are having. So this can happen, and there are various mechanisms that can be used to overcome these problems of underfitting and overfitting. That is something which we will be discussing at a later stage, not now. It's not an appropriate time to actually discuss that. Supervised learning or workflow, what happens? This is the sequence which we are having. We are collecting examples, different examples, preparing data for that, training a model, and then evaluating its performance, and then we start predicting new cases. So this is exact workflow which is there with the supervised model. The workflow is iterative. When evaluation is weak, go back, improve data quality and features or model choice and train again. So there are numerous things where you can make modifications. That is a continuous process that can happen. First of all, you will be evaluating and what kind of performance you are getting with this. If it is not showing that good performance, you can just make certain changes here and there. You can just go on changing the data, getting a better volume, good quality data, which can definitely have an impact on what kind of results we are going to get. You'll be training a model. We can use different algorithm to train it. So you can improve data quality, feature sets which are there, and model choice. So all of these things can happen. And then worked examples, predicting student performance. If you just see, this is the mini data which is there. It's just an example. For the sake of example, this data is given. Otherwise, data is a huge collection, not normally. A familiar example makes the logic easier to see. So this is attendance, this is quiz marks, and then these are the results actually. Learn the rule. If attendance plus quiz are strong, the model predicts pass. So if we are having strong attendance and the quiz also is quite good, higher number, so student will be predicted as pass. So you can just see this. New student, he's scoring 88. Although 88 is not a number which is there in attendance, you can just see that. And 73 is not the number which we have given in quiz. So based on what it learned, it will be putting it into a category which is pass. So this is something where we need to just concentrate on this carefully. And then common algorithms that we will be using in supervised learning or linear regression. It fits a line for numeric predictions. So linear regression can be used. There can be different examples that can be provided. Logistic regression is in fact used. It estimates class probability. So it will be used for logistic regression will be used for class probability. Decision tree can be used. Splits data using rules. And SVM, in fact, one of the algorithms which is there in the supervised one, it finds a strong boundary. So in this series, the next episode, definitely can be into regression first, and then because it's the easiest place to in fact build the way the training is being done, will be able to build that intuition, so that we'll be able to tell that or explain how the training will be done, how errors will be tackled, and how the predictions can be then interpreted, and how predictions can be done. So that is something which we are going to look and look in next, maybe with some certainly some practical aspects as well, where supervised learning can become useful. So these are areas: finance, healthcare, fraud screening in finance, healthcare, risk prediction. Risk prediction can happen in healthcare, retail, demand forecasting, then cybersecurity, malware detection, education, pass fail alerts. There it can be used in multiple other ways as well, but this is one of the very simplest examples to understand. We are giving in all the fields, we have given very simple examples here. So recommendation rankings in media. So these are the examples where supervised learning can in fact contribute. Learning from labeled examples, we are having a recap, and we'll be concluding here with this episode 2, which is deep diving into supervised learning. Uses regression when the output is a number. It uses classification when the output is a category. We have learned it already. It separates training data from the test data. That is very critical, very important. aimed for the model that generalizes, not the one that memorizes. So we are not looking for something which will be putting it, which we have discussed the problem of overfitting and underfitting. And it should not be, it should be generalizing, it should not be memorizing, so that it can just fit in values to other values. That should not be happening. So next episode, definitely it will be a regression, with the regression with visuals, error and line fitting, and probably we'll be taking examples in Python, so that you'll be learning that. So this concludes, in fact, uh, our second episode, which is there, which was for a supervised learning, deep dive into supervised learning. I hope this would have been beneficial to you. You would have understood this concept of supervised learning, and we have dived a little bit deep into this and tried to understand. We have tried to understand this. Comprehend these concepts which are related to supervised learning, and we look forward that in next episode, episode 3, you will be getting a comprehensive information about some other aspects of supervised learning, plus some practicals that will be done, basic practicals that will be done in supervised learning using Python. So thank you so much for connecting, and in case you are feeling that this channel is beneficial for you, do subscribe to this, or you can leave your feedback, which will be very critical and helpful to us, so that we can enhance future series, maybe on machine learning, artificial intelligence, or some other IT related area, so we can enhance that. Thank you so much once again for connecting.